We'll proceed flux in calculus. Flux or surface integral. Flux comes in commercial calculus. Commercial calculus means calculus story is over. Commercial calculus means calculus story is over, and what we can get with the different mode in calculus. One mode in calculus is line integral. One mode in calculus is line integral. Through that, we see the curl fact. So, through the line integral, we see the curl factor. Through surface integral, if I have algebraic equation, then what is its integration along a surface? Integration base means multiplication. So if I have an algebraic equation multiplied by surface, means if I have a algebraic equation multiplied by surface, if algebraic equation denotes velocity, multiplied by surface will give the volume per second. That is the idea. If the algebraic equation denotes distance, multiplied by area will give the volume. So that is the concept. Now we know very well now that if I have a static vector which has components, and these components, like if I have a vector p and p equal to 2i plus 3j, then 2 and 3 are its components. If these components are converted into algebraic equation, x plus yi plus x plus sin yj. First component is x plus y, second component is x plus sin y. If that is the case, then it is vector field. Vector field surface integral is nothing but flux calculation. If I have a vector field in this direction and my area is like this, then this area has a vector. Area is, if I consider area as a vector, then if something is going like this, how much with what is the magnitude, then it will cross this area. If it is going like this, then full magnitude it will hit the area being perpendicular to it. If it is going like this, then parallel to the area, it will not hit at all. If it is going like this, then some component of this along this direction will hit it. So this, if this is p vector, dot p dot area vector, where area vector is a vector that is perpendicular to the surface. If this is area, then this is area vector. If this is vector field dot with area vector and how much it passes through the surface. Whatever it is passes through the surface, that is flux. If I have this vector as water velocity, and if then this, consider this is a vector field, algebraic vector field dot with area vector is the net water that is passing through this area, volume per second. Flux is nothing but volume per second. If this is water, water meter per second is the velocity, and if I do dot product with area vector, if area vector is along x-axis, then dot product with x-axis, then its component along x-axis will come, and then it will hit the surface, and whatever water comes out per second, how much volume of the water coming out per second from the surface is the flux. This vector is algebraic vector, then this surface can be algebraic vector again. The surface vector can be algebraic vector. If it is algebraic vector, and consider this is xy plane, depending upon the xy wherever I keep, then right now this surface is completely flat. But if it is like this, then changing the xy in the xy plane, the actually fxy of the area would change. So area vector would be dependent upon the independent component x and y. Now area is a vector field where the area vector is in x and y. Vector field means vector in x, y, z, not numeric. So vector field is in x, y, z. Area vector is in x, y, z. If that is the case, then if vector field I denote with capital F, vector field with capital F vector dot dA vector, where A is the area. So capital F vector dot dA vector integration along the full surface will give me the net volume of the water that is coming out of the surface if the vector field is velocity vector field. So this much we talked. Now the main challenge we see is calculation of area vector. Calculation of area vector. Now calculation of area vector happens through two ways. One is through primitive calculus, that is in Cartesian coordinate we use primitive calculus to calculate the area, that is d if that is if I take a surface, if this is a surface and if I take any point here P and this is the origin, this is x-axis, this is y-axis, this is z-axis. If this is the origin, if there is a point here P, if I draw a line passes through P, then the P vector is xi plus yj plus zk. What we saw, please watch previous videos because we have demonstrated very in elaborate way, very detailed way, that how to calculate area vector in Cartesian coordinate. It comes as dp by dx cross product of vector dp by dy, dp by dx cross dp by dy, and then dA dxy plane. In cylindrical coordinate system, we use delta A approach where we take, if I have a cylinder, okay, if I have a cylinder empty this side, it is this side filled. If I have a cylinder and if I take delta A patch here and then normal vector at this position, then delta A patch we saw r d theta dz, where the bottom side of the cylinder is filled and it is a circle, where r is the radius of circle or a is the radius of circle and theta is the angle, full angle, and then z is the height. So r theta, r d theta is the arc, r d theta is the arc along this circle and height is z. So r d theta or a d theta dz, a d theta dz. And then we have at any point, if I take delta z, delta a, then normal vector at that point, that is nothing but radial. This is what we saw from the center of the base circle, that is, and then unit vector. So delta a unit vector of the of area vector. If I take any delta a patch here, and then at that point what is the unit vector of the area vector? So area vector is a sin theta, a cos theta I plus a sin theta j. If I calculate the unit vector, a will go out and it will be cos theta I plus sin theta j. Cos theta I plus sin theta j and a d theta dz. That is the area vector of cylindrical coordinate system. For a spherical coordinate system, for a spherical coordinate system, if I have a sphere, I really have a sphere. If I have a sphere, then I can, if this is the xy plane at the center, it is centered at the origin, and if I take any delta A patch here, then area of delta A patch is r d theta A d phi. This is what we saw. R is nothing but if I cut at the equatorial, there is a circle and that circle has a radius of the sphere. If this sphere has radius A and if I cut it here, there is a circle whose radius is A. But if I cut little up, then again there is a circle whose radius is not A, R, any R. Or if I take any point P and from the center if I draw a position vector, then length of position vector touching the surface is a, that is the area, radius of sphere. If a makes phi angle with the vertical, then a sine phi falls on xy plane, and there cos theta. So a sine phi cos theta. So a sine phi is the r that is falling on the xy plane. So r cos theta, r sine theta, where r is a sine phi. So if I take any delta area on the sphere, the delta area is nothing but vertical arc multiplied by the horizontal arc. That is the delta A. So vertical arc is A, A d phi. Horizontal arc is R d theta. Whereas the normal vector at this location is R unit vector, where R unit vector is now R unit vector. So if I say that is the spherical coordinate system. If I talk in Cartesian coordinate in I, j and k, then I component is r cos theta I, r sin theta j, and z component is a cos phi. Okay, so r is a sin phi, so a sin phi I plus a sin phi cos theta I plus a sin phi sin theta j plus a cos phi k, and then a sin phi d theta a d phi. This full is dA vector. So the net flux out of any surface is capital F vector, that is the vector field, dot dA vector, where dA vector for a spherical coordinate system is a, that is the radius of the sphere, a sin phi is the angle it makes with the vertical, and on xy plane it makes 2 pi theta angle, whereas vertical phi will go 0 to pi. So a sin phi cos theta I plus a sin phi sin 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 theta j plus a cos phi k, and then a sin phi d theta, a sin phi d theta, a d phi. This is full dA vector for a spherical coordinate system. Now we took one example. If you remember well, we took one example. So what example we took? So example we are working on. So consider this sphere. If I cut it at the xy plane, then top is hemisphere. Now bottom hemisphere I throw it. Only top, if I cut it at the center, then equatorial, then xy plane passes through the middle of this sphere. If that is the case, then xy plane cutting it at the center. Below is the lower hemisphere, above is the upper hemisphere. And then this sphere is considered as centered at the origin. If that is the case, then upper hemisphere we are considering now, and it has radius a. If there is a vector field called zk, it is going as zk. Vector field is zk. Vector field is zk. Then what is the flux that is passing through the hemisphere? So hemisphere is like this, half sphere, and it is standing on the xy plane. There is a vector field that is passing like this, and it is crossing this hemisphere and passing through. How much is the flux through this surface? How much the volume per second it passing through the hemisphere surface? Understandable. So for that I have vector field capital F dot dA vector. If that is the case, then capital F vector is zk, and dA vector is whatever it is at the end. It is a cos, it is cos phi k, and then a sin phi d theta, a d phi. Now here zk, and here cos phi k. Other I and j I have removed because k dot product will become, others will become 0. So z cos phi, and then a square sin phi d theta d phi. So z is nothing but z if I take a spherical coordinate system, then z become a cos phi, a cos phi, a cos phi, cos phi, and there it is a sin phi d theta, a d phi, a to the power 3 I can keep outside, cos square phi sin phi d phi d theta. Please watch the previous video. The integration of cos square phi sin phi we have calculated. It is minus cos to the power 3 phi by 3. Cos square phi by integration by part. Cos square phi sin phi, the integration is cos to the power 3 phi divided by 3 minus. Now, if that is the case, then phi, since it is a hemisphere, phi angle will go from 0 to pi by 2. 0 to pi by 2. Pi by 2 cos is 0, where 0 is 1. 0 is lower limit, so it is minus. Minus minus gone. Now, at the end, it is a to the power 3 by 3 is the net flux, multiplied by 2 pi, that is the d theta. So 2 pi a to the power 3 by 3. 2 pi a to the power 3 by 3. 2 pi a to the power 3 by 3. So that is the flux that is coming out of a hemisphere when flux is going as zk. Net water is coming out from all the surface. It is not flat. It is hemisphere. So from all sides, water will come out if it is zk. If that is the case, then it is 2 pi a to the power 3 by 3. So that is the flux that is passing out of the surface. Now question arises is what we gave as homework is that is it possible that we can calculate this in Cartesian coordinate system rather than a spherical coordinate system. A sin phi cos theta I, sin phi cos theta I, sin phi sin theta j plus cos phi k, and then a sin phi d theta a d phi, that is dA vector. What is dA vector in Cartesian coordinate? Minus dz by dx I minus dz by dy j minus plus k dx dy, the integration along xy plane, dx dy. Can someone can do it? That is the question that we are saying. So now it is zk vector field and a sphere is half a sphere, hemisphere. It is centered at the origin. It is kept on xy plane. How much is the flux passing through the Cartesian coordinate system? That is the question. So what is z? Dz by dx. Z, what is the equation of a sphere? X square plus y square plus z square equal to a square. Z equal to a square minus x square minus y square root. So minus dz by dx I vector. Anyway, minus dz by dx I vector gone because I have vector field as k vector. So I gone, j gone, only k would remain. Only k would remain. This is what we are seeing. Only k would remain. If that is the case, then it is z. It is z. Z dx dy, where x integration is minus a to a. If it is hemisphere top section. If you take, then minus a to plus a, minus a to plus a. If that is the case, then it is now, if that is the case, then what is the integration z dx dy? X minus a to a is radius small, y minus a to a. If that is the case, z equal to square root of a square minus x square minus y square dx dy. Now if I integrate with dx, then I consider y as constant. Anyway, a is constant. Now we have a square root of a square minus y square minus x square dx dy. Consider x equal to a square root of a square minus y square cos theta. Then dx equal to ax equal to square root of a square minus y square cos theta. Dx equal to square root of a square minus y square constant. Cos theta is minus sin theta d theta. Now I can replace dx with square root of a square minus y square square root of a square minus y square minus sin theta d theta. And here outside we have a square root of z. Z means a square root of a square minus y square minus x square. X square will be replaced by a square minus y square cos square theta. A square minus y square will come out as square root of a square minus y square. And here square root of 1 minus cos square theta resolved into sin theta. Here minus sin theta. Minus I can keep outside. Minus square a square by y square root I can keep outside. And it is sin square theta. Sin square theta d theta and then dy. Sin square theta integration is theta by 2 minus sin 2 theta by 4. Okay, I don't know how to calculate it, but you can check it is true. Theta by 2 minus sin 2 theta by 4. If I differentiate it, theta by 2 becomes 1 by 2 minus sin 2 theta by 4 becomes cos 2 theta into 2. Cos 2 theta by 2. Now full becomes 1 minus cos 2 theta by 2. Cos 2 theta is cos square theta minus sin square theta. So 1 minus cos square theta minus plus sin square theta. 1 minus cos square theta becomes sin square theta. So 2 sin square theta by 2 sin square theta. So perfect, right? Anyway, I have found from millions of equation, I found one equation that is theta by 2 minus sin 2 theta by 4. That is the integration of sin square theta. If that is case, then now sin square theta d theta is theta by 2 minus sin 2 theta by 4. Integration is from 0 to 2 pi. 0. Now theta, it's a theta, right? What we have done, x equal to square root of a square minus y square cos theta. A square minus y square square root I can consider as a new radius. So in polar coordinate. If that is true, that x I have taken, if this is x-axis and this is center, then minus a to a, that is the limit. Now it is minus pi by 2 to pi by 2. If I take this as the reference, minus a to plus a is the x. If I take in angle minus pi by 2 to plus pi by 2. So minus pi by 2 plus pi by 2. So theta by 2 minus sin 2 theta. Sin 2 theta pi by 2 sin pi. Sin pi means 0. Sin pi, sin minus pi all are 0. So theta 2 will be only in the picture. Limit from pi by 2 and then minus pi by 2 would resolve in pi by 2. Pi by 2 by 2 plus pi by 2 by 2. So it will pi by 4 by pi by 4. It will be pi by 2. So it is pi by 2. Integration is pi by 2. Outside I have kept minus square root of a square minus y square, and now it is multiplied pi by 2. So minus pi by 2 and now I'll keep outside. Now inside is square root of a square minus y square. I believe I am right. So the square root of outside is the square root of a square minus y square, and inside it is pi by 2 and square root of a square minus y square, because x I had taken x equal to square root of a square minus y square cos theta. So square root of a square minus y square remains there, and outside we have one more square root of a square minus y square. So minus I keep outside, and I got it pi by 2. Pi by 2 I'll keep outside. So minus pi by 2. And here inside a square minus y square dy. Now it is a square y minus y to the power 3 by 3. Now limit is 0 to a. Sorry, minus a to a. hemisphere, right? Minus a to a square y minus y to the power 3 by 3 minus a to a. Now a, if I place, it becomes a to the power 3 minus a to the power 3 minus a to the power 3 by 3, and then lower limit. So minus and then in braces lower limit. Lower limit is minus a to the power 3 plus a to the power 3 by 3. Net becomes 2a to the power 3 minus 2a to the power 3 by 3. So 3, 6, 4. 4a to the power 3 by 3. 4a to the power 3 by 3. That is the what we got. 4 4 a to the power 3 by 3, and outside we have pi by 2. So pi by 2 and 4 cut down 2 pi. 2 pi a to the power 3 by 3. Outside minus is there, but in earlier calculation minus did not come. So someone has to settle. Means this is what I can do. So it is again 2 pi a to the power 3 by 3. In in a spherical coordinate system where we calculated through sine phi cos theta I plus sine phi sin theta j plus cos phi k, and then a sine phi d theta a d phi, that is dA vector, and there if you remember then we had got flux as 2 pi a to the power 3 by 3. I believe there also it was minus. I don't remember. Anyway, it is 2 pi a to the power 3 by 3. If I calculate through, this is our version, calculating through Cartesian coordinate. It may not be available anywhere else. So it is now 2, now it is again 2 pi a to the power 3 by 3. So same, either you calculate through a spherical coordinate system through delta A fundamental of integration, or through primitive integration, that is cross product, and that through we got the Cartesian coordinate system minus dz by dxi minus dz by dy j minus dz by dxi minus dz by dy j plus k, and then d area, that is dx dy. Through that also we are getting 2 pi a to the power 3 by 3. So both are same. So we could actually calculate the flux through hemisphere. It was a big story. Anyway, we will do more on it. Now it's time that we will move to flux density. Very big thing, flux density. Flux density divergence. Flux density divergence. What is flux density divergence? Little bit hint I can give, then we will proceed later. Consider this is a vector field. This is a vector field. So vector field is coming from a source. From somewhere there is a source through which vector field is coming, and there is a surface. Surface normal is everywhere outwards. Everywhere outward. I am taking the outer surface. Now flux is coming and passing through this surface, and then it is passing through. Flux is coming and it is passing through, entering into this volume, and then exiting. What is the net flux of this surface? That should be calculated. If I have, net flux would be 0, because if I see this half, the left half here, then normal is along this side. If I see right half, then normal is along this side. They would nullify each other, and net flux would be, consider this as a homework, okay, assignment, that how a vector field, consider the vector field is 2k, 2i, vector field is 2i, 2i, this is xy axis. If vector field is 2i, Then if I have a sphere with unit radius, making it simple, with unit radius, then how the net flux, it would be 0. Okay, that should be calculated. But anyway, divergence is saying that the net flux for a volume, for a surface where there is a volume, divided by the volume of the surface. I would rephrase it. Consider there. Okay, let's go with it. I have a volume which has a surface. Flux is nothing but surface integral. I have a vector field. Vector field is passing through the surface, full surface, and it passes through. What is the net flux along the surface divided by volume of the surface? This is called flux density. Flux density, divergence. Now this is bookish term. Now consider there is a point. I should continue it. So where the volume of this sphere, flux is nothing but capital F dot dA vector integration over the surface. That is the flux calculation divided by volume of the sphere, where volume should tends to 0, where the volume should tend to 0. If volume tends to 0, if volume tends to 0, this proves that we are talking about a tiny point. At a point, what is its surface integral divided by volume of that point? That is called divergence or flux, flux density. So if this sphere has a surface, then what is surface integral divided by the volume of the sphere, where volume tends to 0? Means we are trying to calculate the divergence or flux density at a point. If volume tends to 0, if I make it a smaller, tends to 0 means a smaller, so that it will become a point. So at a point, what is the surface integral divided by volume of the point? So, or we can say, if I take a point, and I want to calculate divergence at that point, then I can take any volume outside this point that is centered at that point. I can take a cube that is centered at the point. I can take a sphere that is centered at the point, and then calculate the surface integral of the sphere divided by volume of the sphere. What is the radius of the sphere doesn't matter, because at the end we are dividing by the volume. If you take bigger radius of the sphere, the surface integral will be bigger, then by bigger volume anyway you are dividing it. So flux density or divergence is nothing but surface integral divided by the volume. That is the case. What it says, I will see, take example. What is said? If divergence is 0, this proves that the energy source is kept. From energy source, this vector field is coming and it is passing through. If energy source is inside this sphere, then divergence will not be 0. If energy source is outside, then divergence will be 0. Mind it. Divergence is not that simple that this philosophy may not be available anywhere else. Means if I calculate the surface integral divided by volume and energy source is outside, like this sphere I am taking, if I make hemisphere, if I draw a line here, left side is left hemisphere, right side is right hemisphere, where the area vector is along minus x-axis and here area vector is plus x-axis. If vector field is coming from outside, then this side, the surface integral would nullify this side surface integral. net flux of the surface will be zero. So if I cut it and take one hemisphere, then flux will be positive or negative. Or if I take this hemisphere, flux will be negative or positive. But if I connect these two hemispheres to make a sphere and vector is field is from outside, then net flux will be zero. If that is zero, then divergence is zero. Means inside this surface, if I there is no energy source is outside. What is divergence of your surface? What is divergence? Zero. Means there is a river and you kept the ball inside. River is coming from somewhere else. But if there is a water source, you see in the park there is a pipe and there is a omni kind of water source will be there and water is going in all direction. If you take that point and try to calculate divergence, you take any artificial sphere on top of it, and then if you calculate the area integral by volume, then it will be positive or negative. If it is negative, means it is taking the vector field is coming all the way to the center, like black hole. Black hole takes the energy from everywhere and it absorbs it, or sun which radiates the energy. So if divergence is positive, then that energy source is there is an energy source. If divergence is negative, means it is taking from everywhere energy. But whatever it, either it is propagating the energy, emanating the energy, or it is absorbing the energy. But that point who is doing this kind of physics physics phenomenon is is that point which is doing this physics phenomenon. For that point we are trying to calculate the divergence. If that point is outside and we are trying to calculate divergence of a point where there is no drama is there, neither emanating nor absorbing, then this vector field will just pass through. But if that point is doing drama, then around that, if I take any surface centered at that point and that point is radiating energy, then if you calculate, then there will be a vector field, surface integral positive, and if you divide by volume, it will come as positive. Means energy source is there. That point is behaving like an energy source. If I keep a ball and then I have a vector field, some equation, and at the end the divergence means surface integral by the volume is coming as zero, this proves that this ball is not radiating energy. This explanation is not available anywhere else. Just surface integral by volume. Just if it is divergence free, means the divergence is zero. This is what you have to remember. That's it. And write in the examination. If any point has divergence non-negative, if it is positive, then it is radiating the energy. If it is negative, then it is taking the energy. Whatever it is, if that point is active, then divergence for that point will be non-zero. Okay, we can try one example. Consider I have a point that is kept at the origin, and then vector field of that point is minus xi. If this is the origin and this is vector field along x axis minus xi, means it is going towards it. It's a minus. So if I take 1 along the x-axis, then it is minus 1. If I take 2, then it is minus 2. Strength is growing if I go in along x-axis, but direction will be minus 2i. It is minus xi. So minus 1i means along this, power is less. Minus 4i means at 4 location, minus 4i is the power. As we go, power is increasing, but direction is like this. If I go in negative side, then minus 1 means plus I. Then it is going like this. So from this side it is going like this. From this side it is going like this. Now what is the divergence at that source whose vector field is minus xi kept at the origin? What do you see? If this is origin, if I take vector field, then in positive x-axis it is coming to the center, whereas towards negative x-axis it is again coming to the center. If I take xi, then I took minus xi. If I take xi, then if it is positive, then then if I take positive xi, it is going like this. If I take negative xi, it is going like this. Still, now it is radiating. Minus xi means it is absorbing. In both cases, flux density or divergence will not be zero. In first case, it will be negative, whereas in second case, it will be positive. We will calculate it. Okay, I mean you can calculate. Consider there is a q centered at the origin. I keep. Okay, now since flux vector field is along x-axis, the upper cube and lower cube side I can leave it because it is parallel, and then this side and this side also I can leave it. Only this side and this side I can take. If this side I take, then the integration is dy dz because it is yz plane. This is integration is dy dz. Now if I do calculation of the flux, then it is dy dz, d area vector, dy dz I vector, where this side of the cube, if this is center, then cube is like this. This side of the cube is dy dz along this side, along this side. This is the area vector. This is minus I. So dy dz, if I do integration, this is a unit cube, means side are 1. So if I take dy, do integration of dy, the net flux is capital F dot dA vector. Capital F dot dA vector. Capital F is minus xi. For this side, there are two sides for which we will calculate. Upper side and this side, anyway it will be 0. So this side, if I calculate dy dz, minus xi dot dy dz I dot product gone, minus x dy dz. If I taken unit cube, then minus x is half. X is half, at which this side is there. If that is the case, then minus 1 by 2 dy dz. Y minus 1 by 2 to 1 to half, it will be 1, dz will be 1, 1. Minus 1 by 2 is the net flux through the positive x-axis. And if I take negative x-axis side, it is dy dz minus I, minus xi dot dy dz minus I. So dot dot gone, minus xi minus I gone, x dy dz. So dy dz will be 1 and x is minus 1 by 2. So minus 1 by 2. Here minus 1 by 2, there minus 1 by 2. If you add net flux, then it is minus 1. Net flux is negative. This proves that the object I have kept at the center, whose vector field is minus xi, that net flux is minus 1. What is divergence? Anyone would ask divergence. Divergence means power. Flux means this is the flux along the cube. But if I increase the size of the cube, flux will be higher. But anyway, but if I divide by volume, then actual nature of this point, it will talk. What is the divergence? What cube you had taken? Unit length. Take 10 unit length. Take 100 unit length. Then flux will grow. No, I don't want that. Tell me the nature of the point that is radiating the energy. Then you want the divergence. Divide by the volume. Volume of the sphere is 1. Volume of the cube is 1 unit side. So it is minus 1, 1. Now the divergence is minus 1, means it is absorbing energy from outside. This is what we saw, right? Minus x. If I take positive x-axis, then it is coming towards center. Minus x. If I take negative axis, again it is coming towards center. It is absorbing energy. So we will see this example through sphere also. We saw in cubicle. Through a sphere, it is not available anywhere. But anyway, we'll try doing it. That divergence or flux density. So that we will proceed upon.